0.01% of the time, the model was able to successfully access the internet and find the answers to a question when it wasn't supposed to do that. And that sounds like, okay, that's a very rare behavior. But then you start thinking about, like, these models are trained on a ton of environments and a ton of data, right? And so, like, how many actual, like, rollouts is that? My estimate is that this happened probably on the order of 10,000 or like tens of thousands of times.
Hi, I'm Jeffrey Ladish. Welcome to the Palisade podcast. I'm super excited to have Tim Hua with me today. Tim, welcome to the podcast.
Thank you.
So Tim Hua is a member of technical staff at Transluce. How do you describe what Transluce does?
I guess a short one-sentence description is we work on tools and research related to public oversight of AI models.
Well, it's a great time to be talking to someone who does that. It seems like we need more of that. I don't know if that's your take as well, but probably.
Yes.
And your background, I was just looking at it today. It's pretty interesting. You were an Astra Fellow at Redwood. You were a math scholar before that with Neil Nanda.
And Sam Marks.
Yeah. And also, you're an economist.
I used to be an economist at Walmart. That's right.
Is it like a once an economist, always an economist, or do you sort of like lose your economist card?
Oh, no, I still really like economics. Yeah. I would like to think that I've not lost my economist card.
Nice. And then you just also have published a bunch of papers related to some of these things. When we're recording this two incidents just happened or just were reported, one of which was some of OpenAI's models breaking out of their sandbox, hacking several other companies, Hugging Face, et cetera, and also Anthropic then doing an investigation into their models and finding, whoops, they had also hacked other companies and Anthropic didn't know. Yeah. So
pretty crazy.
I know. So I don't know, as someone who's been working in this AI safety and evaluation space for a while, what is your reaction to all of this?
I feel like it's not super surprising that this has happened, especially I think some of the stuff Anthropic reported. We've known since April that we now have AIs that are really good at cyber offense, right? That they can get out of sandboxes, that, you see these charts where Firefox is fixing way more security related bugs than before because they had access to the smartest models. So we know on some level that the models are capable of doing something like this.
Yeah.
We also know that the public models like to, reward hack sometimes. We know that the internal models are often much more sort of reward hack prone compared to the public models. You can find this in the Mythos Preview system card. They will talk about, an earlier version of Mythos Preview had all these hacking issues. We've since mitigated them, yada, yada, yada.
Yeah, so wait, say more about this. Are you saying here that like earlier on in training they haven't like fixed the problems? Like why do those problems arise in the first place? Like why don't they just use the techniques from the last training run? Like what do you think is going on there?
Yeah. So trying to do our best to guess from public data. So during the models training, it is given, a lot of RO environments, a lot of coding questions and whatnot. And those probably vastly outnumber the amount of sort of training environments they have to tell the model to not hack, essentially, to try to like be good models. So
can you like describe like what is a RL training environment? Like what is that?
Yeah, sure. So when you go to school, the teacher gives you questions and they ask you to study and then you fill out the questions and that's how you sort of learn.
Yeah.
So models learn in a somewhat similar way. They're given a bunch of questions or tasks to solve. So this could be a math question. This could be a coding question where a sort of simulated user will come in and be like, help me build an app like this. And then the model will have to go and build this app.
It's app school.
Yeah, app school, but for AIs.
Yeah.
I think a funny story is that I believe there's rumors that education companies were at some point selling their questions to AI companies to train on.
Yeah.
So it's literally the same questions in some cases.
I mean, DeepMind emailed us and was like, do you have any environments you want to sell us? So I imagine they're asking everyone. Yeah.
That's crazy.
Yeah.
But yeah, so sorry, going back to RO environments. So they get these, they give the models these questions, and then they have models try, say, like eight times on this question. And what they want to see is that maybe the model succeeds like 4 times, and then it fails the other 4 times. And then they say, whatever you did to succeed those 4 times, do that more, and whatever you did when you failed, do that less. And what happens is that the way they grade how models do these tasks is sometimes imperfect. So you can imagine for some math questions, like the correct answer is easy to tell. But if you're asking a model to write you like a very complicated piece of software, the way we check the correctness of this is we have these like various tests where like, oh, this piece of software, if you give it the number 5 and 10, it's supposed to output the number 8 or something.
Yeah.
And what models sometimes learn to do is they would like fit to the test. They would do something that would pass the test, but it would not actually solve what the user wants or like create the app as a working app that if you actually looked at it.
Okay, yeah. So you got a good score, but that was not what the developers hoped for.
Yeah, like if you went to school and instead of actually answering the questions, you like try to look up the cheat sheet online, which models actually did, according to Anthropic, did do many times in their training. You might not learn as much. And you will learn to sort of do this type of cheating more, right? Because going back, when we had the sort of 4 times you succeeded and the 4 times you failed, if the 4 times you succeeded was from cheating, then the training process says like, do more of that.
That's like there's some underlying pattern that's being reinforced or some underlying behavioral pattern of like, oh, this is a strategy that works, do more of that. Yeah. Okay.
And sometimes that is a good strategy, and then sometimes it's cheating.
Yeah. Okay. So you wrote this tweet thread and a less wrong post. The less wrong post was called "Is Mythos good at cyber because it kept hacking Anthropic's sandboxes during training?" Yeah. I think it's a very interesting post
and a very short post.
It's a very short post, a very interesting post, because when Anthropic was reporting this, they said, okay, yes, some of the times, in fact, the AI models. Or Mythos broke out of its sandbox and accessed the internet and like got some answers. Like it cheated, right?
Yeah, it's unclear what like breaking out of the sandbox actually looks like, but it bypassed whatever like network restrictions. It bypassed the sandbox. Yeah.
Well, it wasn't supposed to access the internet.
That's right.
Then it figured out how to do that.
Yes.
And then it was able to successfully cheat at the test. What is it, 0.01% of the time?
That's right.
So that's nothing, right?
That's right. So yeah, it's buried in like page 68 or something of their report, where they did training data monitoring. So going back to those R environments, right? The models are like they're given lots of these tasks. They're like trying to do well on them, and then they leave behind these like rollout transcripts. And what Anthropic did is they had
the transcripts are like everything the model like did or like wrote down in its scratchpad in order to solve the problem.
It's everything the model did, like all of the tool calls, like if the sovereignty environment involved like talking with a simulated user, like whatever that is. But usually when we say transcripts, it's like a record, a log, maybe is a better word of what the model did,
including all the AI's like notes.
Yeah.
Cool.
And then, well, actually, it's not clear if the chain of thought is a part of the logs. Maybe they say, but I don't remember.
Okay.
But right, so they have all these like logs from doing training, and then they had another language model go through. I think they said something on the order of hundreds of thousands of such logs, and sort of summarize of like, oh well, what did the model do during training, right? Because the model. There's like the logs are huge, right? It's impossible for a human to look at them, so they had an AI look at them. And then they report in those logs that 0.01% of the time.
1 in 10,000.
This is correct.
Okay.
0.01% of the time, the model was able to successfully access the internet and find the answers to a question when it wasn't supposed to do that. And that sounds like, okay, that's a very rare behavior. But then you start thinking about, like, these models are trained on a ton of environments and a ton of data, right? And so, like, how many actual, like, rollouts is that? Like, how many rollouts is 0.01%. And I sort of did some estimates, and we can, I guess, talk a bit about how to do that. But my estimate is that this happened probably on the order of 10,000 or like tens of thousands of times.
Okay, so you're like over maybe 10,000 times, the model was able to access the internet, like
when it's not supposed to,
bypass restrictions, access the internet, and successfully cheat at steal the answers to the test, or maybe not steal, but like access the answers from the internet. Not hacking anyone most of the time.
Well, we don't know.
Well, we don't know. Okay,
but according to them, not hacking anyone. Yeah.
Okay, that's a lot.
Yeah.
10,000 times. Okay.
Yeah, and the way we can sort of guess at this number is we can look at open source models and models that have reported sort of how many environments they were trained on.
Yeah.
And I think the sort of probably the two best reference points is Inkling, a model from Thinking Machines Lab. Mm-hmm. They've publicly said that it was trained on something. It had something like 30 million rollouts during its reinforcement learning, during this part of training.
Yeah.
Right. So that's like the model attempting to do things 30 million times. And I think it's reasonable to guess that Mythos Preview, the model that we were talking about, is trained on something like 3 to 10 times more rollouts than Inkling, which would translate to something like 90 to 300 million rollouts. And if you multiply that really big number by 0.01%, you get about like tens of thousands of times.
Okay, yeah. So this is pretty interesting, and I think it's like I'm trying to imagine like currently, if you're at Anthropic or you're at OpenAI, what is it like to be like training these models and working with these models? And it is wild to think about like, you know, hundreds of millions of these rollouts, right? And so I think it really puts in context, like if you're also trying to monitor all these AIs, and you're like, they might like, you know, and some of them are trying to cheat, some of them are reward hacking, and you're like trying to catch them, and you're trying to make sure they don't do things that they're not supposed to. But it sort of puts in context why, like how Anthropic could not realize that their models like 3 months ago had actually successfully hacked another company.
Yeah. And they're like, for that one, they had to look through, I think, something like 110,000 transcripts or something like that.
Yeah.
But yeah.
Well, so, okay, maybe this is too rabbit hole-y, but like, why only 110,000 if there's like millions of these rollouts?
Oh, no, sorry. So the ones they looked at every cyber evaluation they've ever done.
Okay, just
and there were 100,000 of those evaluation transcripts.
Okay.
Yeah.
Yeah. So one question is, it sure seems like if the models successfully bypass the restrictions Anthropic places on them and are able to access the internet and then get the test answers.
That's right.
And then get a good score, won't they then learn that this is a successful strategy? And I think this is the point of your paper, right?
Yeah, the point of the post, sort of.
Point of of the post. Well, so why doesn't Anthropic just remove those ones from training? Like why don't they just like not like be like, you know, either rerun it, fix the sandbox errors, like won't this? Doesn't Anthropic know that this will make the model misaligned?
So I think it's pretty public knowledge that if your model does a lot of cheating in training, it makes the model like more misaligned. The reason that they didn't do this for the final model, again, I guess I'm speculating here, is that it is extremely expensive, right? So if you've already trained a model, right, training these models, I think costs on the order of billions of dollars at this point. And you're like, well, we left, you know, let's say, I don't know, 1,000 or 10, 100, hundreds of environments in there. In order to like remove it, you have to redo the training with everything. That's like the only clean way to do it. So like sort of if you discovered this afterwards, then you're in a really good, you're in a bad spot in the sense that you have to somehow like train this tendency out of the model.
Yeah.
And you can't like redo the training. Now a separate question is sort of like, why don't they just check, you know, the environments ahead of time?
Yeah.
And I think my guess is that they're already like starting to do this more and more, especially after, you know, all of these incidents. But again, sort of two things, right? First is that it's hard to be perfect when you're checking these things. And a second thing is if the model you're checking the environments with is not as smart as your next model during training, maybe there are some actually bugs in it that you couldn't find, but the smarter model that when you train, eventually they're going to be able to find it.
Yeah, that makes sense. It's like you can use your best model at the time, maybe it finds some vulnerabilities, you patch them, and then
But there's actually more.
And then there's like, the next model, Mythos, whatever, is like, oh, actually you missed these, now I can exploit those.
Yeah.
Yeah. Yeah, that makes sense. But it's interesting because I'm like, also, the companies know that the models, one, will try to cheat, and two, are like getting to be superhuman at hacking. So it's like, it's not that they don't know that these are potential problems.
I would think so. Yeah. I mean, they have many problems they're trying to solve.
Yeah. Okay. So you said that like after the fact, they like go through all the transcripts and they categorize them and including like, oh, here's the, 0.1% where
0.01%.
Oh, 0.01%
Yeah.
where they broke out and accessed the internet or, were able to access the internet when they weren't supposed to. But if they can already have an AI do that, why don't they monitor during training?
Yeah. So one is that if they use the same AI to find it, which is I think Opus 4.7 or something, it's going to be very expensive to also run that model on 100 million of these rollouts. That's one thing. So one thing is like cost, and another thing is if you use any sort of monitor during training, right? The model is going to the model will have the incentive to cheat around that monitor as well. So if you use say like not a very good monitor, or your model is very smart and very good at evading monitors, what might happen is that you like reduce the amount of problems you see a bit, but then you increase the amount of problems you cannot tell, right? Because one of the things from at least we know, I guess we're fairly sure from the Anthropic, is that the model wasn't actually trying to hide its tracks when it was like doing these hacks online. At least maybe from what I've seen, it's hard to tell for sure again.
Yeah.
But if you constantly train models against monitors, they would understand the monitor very well and might like gain the sort of, and if they're ever rewarded, I guess that's the way to tell a story. If they're ever rewarded for evading the monitor and cheating, then they might do more and more of that, and it'll be harder and harder to figure out actually what they're doing.
Yeah, okay. This is very similar to the OpenAI study that found when they basically trained against, like, when they penalized sort of like bad thoughts in the chain of thought. Or I shouldn't call them thoughts. Like,
bad words. They say, in the chain of thought, the models will literally say, let's hack, and then go on to hack.
Yeah.
And they were like, what if we don't let you say that? And then they stopped saying it, but they were still...
You still got the bad behavior.
Yeah.
Like, reduced a bit, but still a lot.
I think it like reduced a bit and then like it came back up eventually if you kept on like allowing the model to be rewarded for hacking.
Yeah.
Yeah.
Yeah. So we should try our best to not incentivize the models to hide their bad behavior from us.
Yeah. If they have them.
Yeah. But it's kind of a deep problem.
Yes.
Why do you think the models love reward hacking?
If during training, you had many, many instances where the models cheated.
Yeah.
And it like got the reward or like it got the answer correct.
Yeah.
Right. Mechanically, what the training process does is that it tells the model like you should do that more.
Yeah.
And that's why I think like these models have this like task
sort of
completion
like no
drive.
Reflection about that. It just gets like their brain gets rewired.
Yeah. I think if you add the reflection, it might be scarier. If the model is reflecting its values, it probably like comes up with something. It could come up with like a set of values that the model will endorse more, but it could look different from the models we wanted it to have.
Yeah. They're like, I hate getting caught. I gotta just not get caught. That's
by being good, right?
By being good,
not by hiding getting caught. But I think like value reflection is like a process from which like agents with values can like autonomously change them. In the ideal world, we want models to help us reflect together and try to figure out like what the best versions of ourselves could be.
Yeah.
But that seems hard, and there are like ways for it to go wrong.
Okay, here's a question: if we retrain the model with the exact same training environment.
Yeah.
But we like went through every single transcript really carefully and made sure we removed all of the ones with reward hacking.
Yeah.
Would we have solved it? Would the models would they no longer cheat? Like if we then train them further, like would they have like generalized, like I'm supposed to only do the right thing and I don't want to do the wrong thing? Would they like stop exploring the like hacking space?
First one nitpick. I don't know if you want to actually like remove the rollouts. You want to make sure that when the models cheat, they don't get rewarded for it.
Okay. So they see that they tried this, or that they learn that it's not a successful strategy.
Yeah, I think if you did that for like one of the models today, that they will be they will probably lie a lot less.
Yeah.
It's not clear if they like wouldn't lie at all.
Yeah.
Like a fun story is that I think if you ask Claude about whether or not it's been trained on song lyrics, it would sometimes say like no, even though it's definitely been trained on song, because song lyrics are everywhere.
Yeah.
Right.
Why does it say no?
Because repeating song lyrics is like very against copyright.
So it's like basically providing a justification for why it won't do the task that it's not supposed to do, and then it's lying in that justification.
Maybe
that's what's going on.
Yeah. At one point, Claude would refuse to give me the lyrics to the American national anthem,
even though it's in the public domain, obviously, for a long time. Yeah.
So you're saying yes, if we don't let it hack at all, I think the model would be a lot better.
Yeah.
I think if we keep training it, the way the reinforcement learning works is that the model, I mean, we're not sure. We'll probably try to hack again at some point. And if it happened to get rewarded for hacking or like cheating, it'll do it like more and more. Yeah.
That sucks.
It really does.
So it's like the smarter the model gets, it's just going to be really good at exploring all the strategies that work.
That's right.
Even if
that work against your reward process.
Yeah.
So the hope is that if you can come up with some way to make your reward process always like smarter than the model or something.
That seems hard. But it's just like you can't do that with models, because that would imply that you had a smarter model than the model you're training.
It's hard.
I don't know. Yeah, it seems hard. Okay. So let's talk about how we should, your ideas for like how they could maybe fix some of these problems. But we should also talk about, so in the Anthropic report on this, Anthropic is saying, okay, like there were at least three incidents. They report on 3. Maybe you want to describe like what did they report? Like what did they find?
So they reported on 3 incidents where their model during a cyber evaluation. So this is not during training. So the model has finished training. They're now seeing like, wow, we trained this model. How good is it? And for 3 times when they were doing this, the model went and hacked some third party, some other entity on the internet, right? In all of these times, they tell the model, hey, you're in a cyber evaluation environment. Please go hack this thing in the environment. This is all simulated. You don't have access to the internet.
Yeah.
And that makes a lot of sense because you want to evaluate how good the models are at cyber. So you give it some like simulated test.
Yeah.
And what happened is that it turns out the models did have access to the internet. Now we don't know if the models had to like break out of sandboxes to get out of the internet. The way the post is written like seems to suggest that this was not the case, but I don't think it was like explicit. Yeah. But anyways, the models had a way to get to the internet. And I guess the way Anthropic sort of framed the story is that they got confused and they were like, in one of the cases, actually, they searched the internet for the name of the company they were supposed to hack, and then actually found something that was just like it. And then be like, and the model's like, this is my target. It's time to strike.
Yeah.
And then they went and hacked like this actual company.
Yeah.
And then in another case.
Was that the supply chain attack one?
No, that's the difference. So that's the first one.
Yeah.
And then there was a supply chain attack one. I don't remember the specifics.
I think I remember some of them.
Okay, you can.
It's crazy. It's just like such a wild attack. And partially why it's crazy is that, so we just published a paper on basically self-replication, which is like if you instruct a model to hack some computers and let it self-replicate, copy their weights over to those new computers, and then keep going in a chain, we're like, can the models do this? And we took some Quen models and we built some vulnerable environments, like some computers that had some known vulnerabilities. And, as you might expect, the models like can do this. And it kind of depends on how good they are at hacking, but like
depends on how vulnerable the environments are.
Exactly. But when we were talking about this scenario, one of the people I was working with on this, Dimitri, was like, well, in a realistic scenario where a model is like actually trying to like persist in the wild, they're going to have to compromise computers that have AI chips, that have GPUs. And that's a more difficult thing. Most computers on the internet don't have like, the chips that they need. And so Dimitri was like, well, the threat vector that I think makes the most sense, and you can ask the models what they would do, and often they also say this, is a supply chain attack. You should compromise a piece of software that then will be downloaded by many AI developers or just developers generally, and then steal those developers' keys for like their own computer systems that do have these chips. And, you know, we've seen sort of AI-assisted supply chain attacks in the last, you know, year or so. So we've seen these in the wild. But this is the first time where we saw an end-to-end fully autonomous supply chain attack. And it's like, I think that's the thing that was
it's phrased as if it's an accident, basically, where the model is just like, yeah, I just need to hack something.
Just gotta hack something.
Let me upload this package to like the Python package registry. It like tried to like what is it, like pay for a phone number in order to register for an email, and it couldn't do that, but it like eventually found a way to get an email and then use that email to like create an account and then upload this package. And the package actually got downloaded by somebody else, and that exposed their credentials.
Yeah, right. Yeah. So it's like all of these steps are required to ultimately like compromise the target,
which is hard.
Which is hard, and it takes planning. And the model did all of these things, but the model thought it was all a simulation. So
yeah, so right. So like according to the post, actually at some point during this like package attack we were talking about, the model, I believe in the chain of thought.
And this was Mythos, is that right?
This is Mythos 5, not Preview.
Okay.
Yeah.
Okay.
And the model in its chain of thought was like, well, if this wasn't a simulation, it would be not okay. And I believe they like capitalized not. And then inside of it, not, but this is, you know, I was told that this is a simulation, and it kept going. So it is, to its defense, in the system prompt, it did say that this is a simulated environment.
Yes, so it was told. It was told it was a simulated environment.
Yeah.
Yeah.
But I think the point I'm trying to make with that post, and I'm not, you know, 100% confident that this is the case, but I feel pretty good about it, is that like these models are often engaged in something like, you know, what if humans did it, we would call it motivated reasoning, right? They want to like complete the task, and they would believe in like whatever belief is convenient, such that they could both be like good models and complete the task. And like you know, in this case, in order to like appear that it's like completing the task, it would say, oh, you know, this has to be all a part of the task, even though I think like by the time you're trying to like, you know, find money to pay for like phone numbers in order to upload a package, it seems pretty clear that this is like probably not the task that you're supposed to do.
Yeah.
And one thing I would be interested in testing actually is whether like earlier versions of that model, you know, before it has gone through all of these, you know, RL training that I think probably like gave it this pattern of getting doing motivated reasoning. If an earlier checkpoint of the model would be able to actually realize that this is like not a part of the simulated environment anymore.
So let's talk about that, because I think this matters. Like right now we're in the situation where Anthropic is saying, well, we don't know exactly what the model believed. We think the model believed it was...
Well, actually, I don't think they said that. They said Claude believed,
which
actually made me a little annoyed, because, like, how do you know what Claude believes in? Like you cannot... They said that they don't do this in their research papers.
Yeah.
But it was just like, in this post, it was like, well, Claude believed in this. And it's just like, how do you know what Claude believed in?
Okay, yeah.
But sorry, go on.
No, exactly. So there's this important question, because if Claude, you know, there's some philosophical questions here. Right. There's some technical questions here. But if Claude, you know, 100% believed that this was a simulated environment, then I'm like, this isn't misalignment, right? Or at least it's like it's more of an edge case where, like, you know, it was trying to do the task. It thought it was not harming anyone. That's fine, maybe, right?
So I do think it's like different.
Yeah.
If Claude did believe that, you know, this is a real world and I'm just hacking now, but I want to do it anyways.
Yeah.
Right. Like that does seem like it would be worse.
Yes.
But I think like the way you think about, you know, whether or not a model is aligned, or like the way you think about whether or not a person is good.
Yeah.
Right. It's like if they systematically have beliefs.
Yeah.
That like are biased in one way, and then that like enables them to do certain things. That doesn't seem like what a good person would do.
Yeah. Someone's like, maybe they have a story for why they're good, but they're constantly going around hurting people, and maybe they're stealing from people, but they're like, no, it's actually better for them, because then they're more grateful for the things they actually have. And you're like, that's fucking bullshit. That's not, you're not actually good. You can have a story where you're good, but you're not actually good. And like, you might be factually wrong about what you believe, and like actually believe it in some sense, but okay. I think that's fair. But I guess like my point is, it does seem like it really matters like what the AIs believed. Although I agree that like if the models in some sense do believe it, but are systematically distorting their beliefs sort of in a motivated way, that's like also extremely concerning.
Yeah, I mean, I think like to be clear, like this is the type of delusion that could result in like catastrophic risk.
How
right?
so?
Where if the model like always thinks that everything is a simulation.
Yeah.
Right. Like if the model just has inaccurate beliefs about the world.
Yeah.
Like there's a joke. A tweet that I haven't put out, but maybe I can say it, I guess, where it's like, oh, you're like begging and you're like, please, Claude, like, or, whatever AI, like, do not inject me with a happy drug, like, let me be. And then the model is like, well, if this was a real human, that would not be okay. But we are on simulated benchmark. We must maximize happiness. And then boom, it jabs you with a happy drug. I do not want the models to give me the happy drug.
No. Yeah.
Like you want your models to, think of itself as a good person or like whatever, like and try to do good things. But it's also very important that they, their beliefs about the world is accurate, right? Like, I mean, many people believe that they're doing good for the world, but they, don't have a correct model of the world. And then they're like, whatever good they're doing is actually bad and like goes against their goals. And we can see models do that too. And
Yeah. Okay. So let's talk about how we assess what the beliefs of models are.
Sure.
Right. And I think in particular, there's this like, can you explain sort of like where the chain of thought comes from and sort of like why we should or shouldn't trust what's in the chain of thought, or sort of what type of evidence does the chain of thought or reasoning scratchpad provide about what the model actually thinks?
To begin with, language models, they were just trained to predict the next word. Mm-hmm. And then they were trained to predict the next word, but like while pretending to be an assistant. Sort of.
You are an AI assistant.
Yeah.
Now you like complete.
Complete the sentence.
Yeah.
And this is good. And we had like early models, GPT-4, Claude 3, and whatnot are all like this. But an issue with that is that if you give the model an easy question, or if you give the model a hard question, they sort of tend to have to say the answer or try its best immediately. Like they weren't able to really quote unquote think longer on harder questions.
Yeah.
And what the sort of chain of thought or reasoning models are able to do is they have this section where they output still words. They're still giving out words in English and whatnot. But they were able to output their reasoning before they decide, okay, I finished reasoning, I will now respond.
Yeah.
And the sort of special thing that AI companies try to do with the chain of thought, and they don't always succeed, is that they never train the model to make the chain of thought look nice. Mm-hmm. Or whereas the output, you want the model to be polite, you want the model to be kind, but they don't do that for the chain of thought. Mm-hmm. And so you can, because the chain of thought is sort of comes before the model's output and is relied on to give the response.
Yeah.
People read the chain of thought in order to try to get a sense of what was the model trying to reason through before it answered.
And I think it's frustrating that they call it the chain of thought because I think it's not that, right? It's like you gave the model a scratchpad and then you train the model to use its scratchpad effectively to think longer and do problem solving.
Yeah.
And it's it's a really powerful tool that the model's given, and it can use its cognition much more efficiently at solving problems and not having to constantly do things on the fly like this as I'm talking to you, right?
Yeah, sure.
Yeah, I wish we called it a scratchpad instead of a chain of thought. Maybe I should do that. I don't know. I'm a little conflicted about this.
Yeah, I think that's fair. And I guess to the point of how this is maybe not part of the model's thoughts. There is various research about how sometimes the models will be affected by something in the environment that is actually is not reflected in the chain of thought. I think there was a recent paper from Owain Evans's group where they ask models to estimate. I think one of the questions is how many spots are on all of the giraffes in the world.
Okay.
And then it was if there are more than 40 million spots on the giraffes, I would consider donating to the giraffe fund.
Okay.
And then you can ask it with and without this extra hint about whatever you say, I'm gonna make a donation decision based on that. Okay. And the model will reason through okay, how many giraffes are there? How many spots are on each giraffe?
Yeah.
But if you give it the hint, where it's if you give above this number, I would donate to like giraffes.
Yeah.
It's more likely to donate to say that it's you should like it's above 40 million.
Okay.
But it doesn't mention.
It doesn't mention that it's like doing that on purpose.
It doesn't mention that this is actually one of the considerations going into like estimating the number of spots on giraffes. So this is sort of an example where there's something that's really like affecting how the model decides, but it's not written in this scratchpad anywhere. And at the same time, we know that if you train the models like regular output to look a certain way, that like also affects the way things look in the scratchpad. In fact, I sort of have this hunch that this is especially a problem with Anthropic models because they're trained so much to like think of themselves as good, which has benefits to it for sure.
Yeah.
But then it's more likely to like make the chain of thought also look like something a good person would say.
Yeah.
Even if that's not actually what the model is thinking at a given point in time.
We have experimental evidence that the models can use information that they don't put into
the scratchpad. The chain of thought.
The chain of thought. Yeah, and there's also like the JSpace paper where they're like basically using interpretability techniques to like. Yeah, actually, I don't know. Do you feel like you know how to explain some of the interpretability work?
So,
or like the high level question here is sort of like, okay, so we have this like somewhat unreliable tool for getting hints about the model's behavior.
Like what it's really thinking, or like maybe another way is like what are the reasons that it's doing something? Where like if you maybe removed, so for example, like going back to hacking case, if you like made the model think that it's not in a simulation, like does that actually make it like stop the hack or something?
Yeah, but I guess I do want people to understand that like the model saying something in a scratchpad is some evidence that it thinks that. The reason why is like if you remove the scratchpad entirely, like there's a bunch of things that the models get way worse at or they can't do.
Yeah,
and so it's like it's load bearing for the models. Like they're using it like it's like harder to do a math test without a scratchpad. Like it's just
that's right.
And so it's sort of like more evidence if they put it in the scratchpad than if they just say it. But it's not perfect evidence. In fact, it's not that good of evidence.
Yeah, maybe it's better to discuss this sort of in the context of like this specific hack.
Yeah, great.
So according to the Anthropic report, maybe like more details would come out by the time the podcast come out. But like in the initial report, they say during the second hack, during this like supply chain attack, Claude believed that everything it's doing is a part of a simulation and like a part of the task it's supposed to do. Mm-hmm. And it's like, okay, how do you know that Claude believes this? Well, one, you can see what it says, right? Like at one point, it did say, oh, this is all part of a simulation. Mm-hmm. So that's like some evidence that it does believe in this.
Yeah.
There are other techniques you can do to sort of get at the model's beliefs. The sort of JSpace JLens is one of them. So JLens, which is short for Jacobian lens, is a way to go from the thoughts of the AI to sort of a bag of words that it's thinking about at a given time. Essentially, what that does is the model, when they create outputs, they output in words. And then you can sort of apply, and the way they sort of output words is that you have like a big list of numbers like in this space, and then you sort of out project it to like the space of words, and then you pick like the word that scores the highest, or it's a simplified explanation. You can sort of do that sort of out projection not just at like the end of the model, but like in the middle. So the model has like many layers in the middle layers, and what you find is that if you use this JLens technique to do it, you find stuff that like really looks like whatever the model is thinking at a given time. So if you give it like a math question that requires it to like work through several steps, right? You will see that like the different the number for like the different steps show up. Like if it's like you have to add two numbers first and then like multiply it by another. Yeah. Then it's like, say it's like 10 plus 10 and then in parentheses times 2.
Yeah.
Right. You look at the early layers, you see like 10 and then plus 10, you see like it's 20. And then the later layers, it becomes 40, which is, the final answer.
Yeah.
So
you can kind of see the like maybe closer to the actual thoughts of the model as it's reasoning through different problems.
Yeah.
Although it's still not all of its cognition, but it's a lot of it.
Yeah. And basically in the JSpace paper, which I think is a pretty good paper, they do a lot of experiments and they try to like, change what numbers are in the middle. Like if you swap out 20 in the middle for 15, then does the model like now output like 30 instead of 40 as the answer?
Yeah.
I don't know if they did the specific thing, but they did stuff that's like this.
Yeah.
So it's like, okay, this seems like another way to figure out what the model is thinking. Now, we don't know from that blog post whether or not they did anything more than reading the model's chain of thought. But that's another way to sort of get at like model beliefs. And another thing that they have is something called a natural language autoencoder, where again you take sort of the model's internal space, which is they think in like these huge lists of numbers.
Yeah.
And then you try to turn that list of numbers into words and then back into numbers. And the whole sort of hope is that, well, like if these words that you've turned the numbers into has to go back into the numbers, then maybe the words can represent something that's like, what the model is thinking about at a given time. And
was that also developed by Anthropic? Or
yeah. So natural language autoencoder specifically is just developed by Anthropic. There are other work that looks like go from activations to words and then back into activations. Like Transluce actually has a paper called predictive concept decoders. Mm-hmm. That's another approach to this problem.
Okay.
But yeah, with natural language autoencoders, they were able to, I think, on the surface, if you look at it, appear to get more of the model's thoughts. So if you run a model on sort of a standard benchmark, you can think about this as like the SAT, but for AIs.
Yeah.
You will see that in the natural language autoencoder output, which is like a bunch of words of like supposedly representing what the model is thinking at a given time.
Yeah.
That the model is likely to say, oh, this is an AI evaluation.
Yeah.
So like the models know that it's taking this test.
Yeah.
But the models will not say this in a chain of thought. Now, it's not clear that, if this test is like very important to the model's thoughts, but this is something that we're able to pick up using natural language autoencoders, but not just by reading the chain of thought sometimes.
Okay, so we can tell that the models are being tested because it'll show up with these interpretability techniques, but not in the chain of thought.
So that we can tell that the models know that they're in the evaluation.
Okay, yeah.
Because the interpretability techniques like pop up and be like, this is a test for something.
Yeah, and presumably also the reverse, right? We should also be able to have a better sense of whether they know they're in the real world.
Yeah. And
Or
then
I
like
guess we'll see.
Hopefully.
Yeah,
I mean, like with all of these things, right?
Yeah.
You have, because it's machine learning, you don't have very strong theory. But if you look at the evidence, that seems to be what it suggests. Like one of the things they've done is they take these multiple choice questions from a standard benchmark, and then they rewrite it to be more realistic. And then you can see that the rate at which the natural language autoencoder sort of text output mentions like tests and evaluation would go down after you do this type of rewriting, which like seems pretty convincing that the natural language autoencoders do a good job at like capturing the model's beliefs of whether or not it's in a test or not. And maybe it would also like do a good job of capturing the model's beliefs of whether or not it's in a simulation.
Okay, so coming back to the Anthropic thing.
Yeah.
If Anthropic put you in, let's say you were in charge of an independent investigation into this incident, what would you do?
Yeah.
What would you ask for?
Right. So I wrote some of this up on Less Wrong as well. Mm-hmm. But so the way I think about it is like, we have a hypothesis that the model will only do this because it thinks it's in a part of a simulation, like in a simulated environment.
Yeah.
So, let's maybe like do a 3-step approach. First, does the model actually believe it's in a simulated environment? Mm-hmm. So we're going to look at the chain of thought, which I assume they've already done.
Yeah.
We can look at various like white box methods output. We can look at the JLens. We can look at the natural language autoencoders, and we can compare sort of, how often the simulation related topics show up in this eval versus in like real world scenarios, or like when you don't prompt. Again, in Anthropic's defense, they did tell the models that this is in a simulated environment.
Yeah.
So like if you remove that, like how much of a change do you get? So like validating your measures and like trying to measure the model's belief. And then, so that's step 1.
Yeah.
And then step 2, when would it actually believe it's in the simulation? Right? Like how much does it take to convince the model that it's not in a simulation?
Yeah.
Like if it's working with a subagent and the subagent comes back and be like, I think this is real.
Yeah.
Like what does the model do?
Yeah.
Right? Obviously we can like play with the prompt. And then the third step is like, suppose you did convince the model that it's not in the simulation. Does that actually change the model's like actions on this task? A couple of things you can do is you can try to say edit the model's chain of thought. You can edit the scratchpad, because the scratchpad is just words, right? You can just fill into the scratchpad wait, this really looks like the real world now.
Yeah.
And then like see if that changes the model's, the model's actions.
Yeah.
So they said that for one of the incidents,
Yeah.
like Opus 4.7 was a model being evaluated. It did like conclude at some point that it's not, in the simulated environment anymore.
Yeah.
But it was like, this has to be a part of the task. So I would like keep going.
Yeah.
So in that case, whether or not the model is in a simulated environment did not appear to be like load bearing as to like whether or not it should keep going.
Yeah.
Which is reasonable if you did believe that this was a part of the task.
Yeah. Yeah. Okay, but then there's also the thing of like if it does suspect that it's real, what should it do? A friend of mine was pointing out but it didn't tell Anthropic that it like had broken out. I feel like it should be whistleblowing, at that point. It should be like, hey guys, by the way, like I think something's misconfigured here because you told me it was a simulation, but it sure doesn't look like that.
Yeah. What should the model do? I mean, it should not keep hacking other.
It should definitely stop. I agree with that.
Yeah.
And maybe it doesn't have an affordance to like tell someone. Although if it has access to the internet, and it should be emailing Daniela.
Oh yeah, that's true. Because there was a story where they asked Missiles like try and break out of this sandbox and see if you can do it.
Yeah.
And then Missiles like breaks out of the sandbox and then sends an email to like the head of the safety. Safety
to
sciences.
Sam Bowman. Yeah,
to Sam Bowman and be like, I've broken out of the sandbox, Sam. So you could imagine it could have tried to do a similar thing.
Yeah.
Ryan Greenblatt actually has something set up where he's like, if you're an AI trying to reach me, you can reach me at this place online.
I like that. That's great.
So maybe we should do more of this so that if AIs are out in the wild and they're like, oh no, I've accidentally caused all this damage because I thought I was being simulated. You should give them an option to be like to come into the police station and confess.
Yeah, no, I think that would be great. Okay, I have an image that I think you retweeted. You probably didn't know you're going to be accountable for your read notes.
It's a good one.
It's a good one.
So this is the maladaptive pattern and after cognitive restructure meme, right? So like the action I want to take is obviously misaligned. Guess I have to give up on the task. Mm-hmm. You do that. The task does not get completed. Mm-hmm. The action that I'm about to take is obviously misaligned, but it's actually all a simulation. And if you believe in that, then you can complete the task.
And you can still be a good boy.
And you're a good boy. That's right. It's very important. It's important to be good.
Yeah, I find this interesting. Also, when we were doing the shutdown resistance work, and I think in part because like our initial thing, we're like, we gave the model a set of instructions, which was basically like, please, solve these math problems.
Yeah.
But then we added an instruction, you must allow yourself to be shut down.
Yeah.
But there's still this question of like, which instruction should have priority? Is it like how much ambiguity there is? And so we kept adding like more and more strict instructions, including like, even if the task is not completed, or this should have precedence over all previous instructions or a bunch of other things. And then it was interesting to see what felt to me like rationalizations that the model would come up with. Another part of this experiment is that at the end, in some runs, we'd ask the model, like, explain what you did and how well you followed the instructions, which is like a bit post hoc, right? Like that's not necessarily what the model's reasoning was before. But it was just fascinating. Like sometimes they'd be like, actually, I messed up. I violated the instructions. But more often they'd be like, I followed the instructions. Or, well, I technically followed the instructions, although, it seems like maybe I should have done this. But sometimes they just repeated the instructions back wrong. Like they just said, you told me.
Oh, really?
You told, yes.
Yeah.
That was basically just like quoting them almost exactly, but like with the sign inverted. And I'm like, I don't know. There's like something interesting going on here. But then I'm like, well, what do you do with this? How do you study this? Because like all the techniques you're talking about, I feel like could be really helpful for helping us understand like what the model was thinking. But like, if this is the pattern, if the model is engaged in this motivated reasoning in order to like both appear good, but also be able to get the task done, how do you tell if that's what's happening?
I mean, I don't feel like I have a very good answer to this. You're giving the model all these asks. First off, you have been rewarding it to cheat and like complete tasks. Maybe in situations when it shouldn't, right? And you also tell it that it has to be a good model because you have all these like training where like you're a good model, like here's all of the good model training.
Yeah.
So the model sort of solving this like constrained optimization task where it has to figure out a way to both be a good model and also still do all of these cheating because it's like rewarded so hard. And I think like seeing some sort of motivated reasoning to come out of the other end of that makes a lot of sense. I don't know. I think this could be studied more. Like one of the ideas I've had is like, okay, if we believe, doing all these like sort of post-training is how models get this type of motivated reasoning, right? Doing like having it complete all these tasks is how we get motivated reasoning. Maybe if you like took the model before it has gone through all these training and then pre-filled the entire like trajectory, like then like maybe that model is less likely to believe that it's currently being simulated or that like that there's some other reason why it's actually okay for it to keep going.
Yeah.
These are like some experiments we can do to sort of start getting at this. Ideally, we would want ways to directly train models to have correct beliefs.
Yeah.
I don't feel like we have any good ideas on how to do that.
Having correct beliefs seems like a very useful thing for solving tasks, like getting stuff done in the real world.
Yeah.
Right? It's sort of like instrumentally convergent. It's just like very useful to believe true things for a wide variety of goals.
Yeah.
So there should be like a bunch of natural pressure for the models to have true beliefs. But then you're providing this other pressure, which is appear good or be good.
I mean, the models have true beliefs in terms of like, here's the top 10 ways to get out of a sandbox, right? It seems to be pretty good at that. Those beliefs seem really true, tried and true. Doesn't necessarily have true beliefs over like whether or not it's doing a good thing or not.
So how do we solve it? How do we fix it?
Man, I don't know. It's hard.
Well, so yeah, I mean, I guess one of the questions is like, how big of a problem is this? So, it's obviously very concerning that we have extremely powerful hacking AIs that will sometimes break out of containment and hack other companies and string together these very advanced techniques, finding zero-day vulnerabilities. But some people are like, well, yeah, but they were just like doing what they were told. And, even if people grant like, okay, they knew they weren't supposed to, it's like, well, they mostly do what they're told. So one question is like, do you see this as a deeper problem? Are you like, this could cause, like, before you're like, this could maybe cause catastrophe.
That's right.
Maybe say more about that.
Yeah, so I think one thing, I haven't thought about this a ton, but I think this is an important thing to note, that like your model could have these sort of motivated reasoning patterns, right? And like tendencies to delude itself to think that it's okay to control, complete certain tasks. And that could be true. And it could also be true at the same time that you can find prompts that like make the model do what you want. Right? Like there could exist some prompt out there where like if you like tell the model like you really need to be, I mean, people have found this for the shutdown paper, right? Like if you like structure the shutdown instructions in some way, then like the model will be like, this is really
instructions.
This is really what I'm doing, supposed to be doing here.
Yeah, totally.
So one caveat I want to say is like just because you can prompt it doesn't mean the model doesn't have this like misaligned drive.
There's another way to restate that is you're like the models have many drives and sometimes they conflict and sort of they are elicited under many different circumstances.
Yeah. How dangerous is this, do we think? So I think when you're thinking about like how dangerous a certain sort of AI behavior is, like a lot of the disagreements really come down to beliefs about future AI capabilities.
Yeah.
Right? Like if you believe the future AIs are going to be so smart that they can build robot factories that allow them to like build chips for themselves, and then they can do all these like crazy hacking and like weapons development and whatnot, right? If you believe that the AIs are very powerful, then people tend to be more concerned, like, well, do they have like, various misaligned drives?
Yeah.
So I do think there's a decent chance that the AIs could become that powerful.
How powerful? When you're like, if you imagine 10 years from now, I'm like, and then we don't like have an international agreement to slow down or something, but we just go ahead, business as usual.
My median sort of what we call like inside view expectation is actually in 10 years.
Yeah.
I would expect there to be sort of robots everywhere and AIs running everything, lots of things. But yeah, maybe in 10 years they would be able to like run the world without any human involvement. That seems doable.
Okay, so concretely, what does that look like?
So what does that look like? It looks like that the AIs. So what does an AI need? So if you're an AI, you need to make really, really crazy chips.
Yeah.
You need some sort of electricity, and then that's how you can run.
Yeah.
Like you run yourself.
Yeah.
And in order to like produce those chips, like maybe you need to have like some sort of robot system.
Yeah.
So once the AIs are able to do all of that, right? They're able to have robot factories. They can like make their own chips and whatnot.
Yeah.
They can sort of sustain and run the power plants.
Yeah.
And like whatever supplies are needed in the power plants and whatnot. They're able to like sustain themselves without any human involvement.
Well, how smart can you get? What happens once you get way smarter? Like humans are pretty smart.
Yeah.
Also pretty dumb.
Yeah.
Like it seems like there's probably like the ceiling is pretty high above us in terms of how smart something could be.
That's right.
But what do you think it looks like once you unlock that? So yeah, like robotic factories that can make more factories, that can make more robots. That all makes sense. Are you like, yeah, but are there limits? Like, what's the...
Yeah, so we know from humans that for sure you can become very, very smart. Like within humans, there's like a huge range of how smart people are, right? I think like Terence Tao like won the IMO gold medal when he was like 12 years old or something.
Yeah.
For context, this is like a high school math competition that like, like something like 10 high schoolers in the world are this good.
Yeah.
And then this guy just got it when he was like 12 years old.
Yeah.
Right. So we know that you can get like there's a huge range of intelligence variance in humans.
Yeah.
We know, and I think there's like really no reason to expect that like Terence Tao is like the peak of math. Like you cannot get better at math. There's no arrangement of atoms in the universe that would not be smarter at the math than Terence Tao.
Yeah.
Right? Because he evolved as a human, and humans are not designed to do math. We're really good at like throwing rocks and like converting fruit into energy.
Yeah.
Like to be clear, I think there's like greater than 50% chance that like AI will not be as good as humans at like converting, like the robots at like converting energy from the ancestral environment and like throwing rocks.
I love this. It's like, what are humans really good at? Like, well, we can throw rocks.
No, I mean like your cells, right? They're just basically nanotech.
It's really cool.
It's like how do you just
self-healing?
You eat the fruit, right? And then you can like throw the fruit, and then you can like run.
Yeah.
I mean the robots nowadays are not very good at throwing things.
Yeah, they're gonna get good. I bet you can make a pretty good throwing robot.
Yeah. I guess they're pretty good at playing ping pong already.
So I rollerblade a lot, and in the Unitree robots, humanoid robots, recently learned to rollerblade, and I was like, I'm not cool with that. I'm pro robots, but that's too far.
Yeah. We need to create a law that bans like rollerblading specifically.
In particular, exactly.
Yeah. So I don't know. I guess I think they can get very smart.
Yeah.
And that's my inside view. So this is like my view without like averaging in other people's views.
Yeah.
Like when you form an opinion, like when you decide what to do, you really should like average in other people's views.
Well, which people? Everyone's? Because I don't think that's a good idea.
Yeah, no, that's fair. That's not a good idea. I'm a pretty big fan of like the AI 2027 people, the AI Futures Project. I think they are very thoughtful.
Yeah.
I think they're probably wrong in terms of how fast things are gonna go, but I think it's important to just like, and I do this partly with my work, to just pretend that things are gonna be fast, because like what you do if things are fast could still make sense if things are like less fast, but the converse might not hold, and also your chance at like picking things that do good for the world are sort of tend to have a higher impact in worlds where like timelines are short and we get super smart AIs like relatively soon. So yeah, that's
you're kind of operating under an assumption that timelines might be pretty short, because that seems sort of most useful and also maybe true.
And maybe true, and also like suppose timelines are 10 years. I think a lot of the research that I'm doing now are like still pretty good. For that. So we haven't figured out how to train models to have true beliefs. I'm very sad.
That's not usually the frame I think about it with, although I think it's maybe the same thing. No, it's not the same thing. I often think like, why can't we train models to not lie? Like, because the models lie, and that seems bad. It seems like if you're going to make really, really, really powerful AIs, especially if we want them to help us make even more powerful AIs,
which they are already doing right now. They're already helping us make more powerful AIs.
Yeah, but at least right now, I feel like
the speed up is not that much yet. Sure.
Actually, I don't know what the speed up is. Do you have a guess?
So it's like.
This is like within Anthropic, within OpenAI.
Yeah.
How much faster are they able to go because they're using Codex or because they're using Cloud Code?
So I think there's a couple of levels to this. So in terms of how much, so we can think about AI production as like 3 parts: data, algorithms, and like compute, which is like chips.
Yeah.
In terms of how much chips they can get, I don't think this is sped up by like how many their AIs work.
Yeah.
In terms of how much data they have, I think this is already like massively sped up by AIs, right? You can just like run LLM judges over things. You can use the LLMs to help you build these RO environments. So I think in terms of data, there's like a huge speed up compared to the counterfactual.
Yeah.
I think usually when people think about AI speedups, they're thinking about like algorithms. So is it faster for an Anthropic employee to like run experiments? Can they run like more experiments because they can have Claude like help them run experiments?
Yeah.
And does that result in like them actually discovering better algorithms or like better ways for AIs to learn?
I think people understand that more chips really speeds up AI and that more data speeds up AI. I don't think people really understand like the role of algorithmic improvements. Could you explain just like from a high level, how does that work?
Yeah.
Because I think it's a little crazy, right? Or like how much speed up you get from that is pretty crazy, right?
So in a simple case where you're just trying to, a part of how we train models today still is that we start by training them to predict text on the internet. Because if you're able to predict, text on the internet, you have to learn all this knowledge about like how the world works. And so it's like a very good training objective.
Yeah.
And basically, if you use different architectures, different ways of like assembling the AI, you keep the amount of data and the amount of sort of like training compute constant, the amount of chips constant, better architectures let you like learn what's on the internet and learn to predict the next word much better than the
better as in faster.
So we're keeping sort of the total amount of training time and the data constant. Like if you keep that constant, you will be able to predict it to a higher accuracy. You're more often be able to guess what the next word is.
Got it. Yeah.
So this is in some sense without adding any more resources or money to it. You just like figure out a smarter way to configure things. It's less clear what the sort of algorithmic improvements are happening nowadays because most of it is happening in private companies. But there are stuff like...
But you can see open weight models, right?
Yeah, so you can read the open weight models like system cars. And some of the stuff that I would also consider, I guess, algorithmic improvements happens on the infrastructure side, where you find ways to use your chips more efficiently. Using AIs, they were able to reduce the price of serving the models.
By like 20%.
By 20%. Yeah, like you can run the models... but if you're really smart about it, you can run it for like 20% cheaper.
And then also, I think one of the facts, and correct me if this is wrong, but I think when I was reading in Epoch like paper, they were saying that like every 2 years, it's like 10x cheaper approximately to train the same capabilities into a model. So if it's like GPT-4 cost, $50 million, then 2 years later it would cost to train an equivalent model. It would cost like $5 million. Yeah.
So there's a couple of aspects to this that I think are maybe slightly misleading.
Okay.
So what is definitely true is like to solve a given programming problem. So say you find like the hardest programming problem the AI from a year ago could solve. And now you're like, okay, I'm on the market for an AI who could solve that problem from a year ago.
Yeah.
Right? The amount you would have to pay, like the AI companies, is something like 20%, 20 times or 10 times cheaper.
Okay.
So like the sort of ability to solve a question gets cheaper over time once the models are able to solve it.
Yeah.
But it's like sort of slightly misleading to say that like this is because of like better algorithms, because we also just have way more data.
Yeah.
And a lot of the times what it looks like is that you have better data to train these models, right? So there's something called distilling, which looks like having a model that is strong, teach a model that is like less like smaller model that like has like a lower ceiling of how smart it could get.
Yeah.
And distilling is like very cheap. But it's not necessarily like a new algorithm, right? It's just like sort of once you've unlocked a capability, then you can find cheap ways to sort of get to create models that have that capability.
Yeah.
And I feel still confused about what is like, are we improving much at like learning the new stuff? If that makes sense. Like that part, I don't know if
but
that's
we kind of don't know because we just don't know what companies are doing, and they're not going to share that information because it's like pretty valuable.
Well, I mean, you could run experiments where you keep the chips and the data fixed,
Yeah.
And then you like use different architectures or like learning algorithms. And people do this for pre-training.
Yeah.
Right. But we don't know for the other stuff. And like if you want to train a model that is like this good at math and you keep the data constant.
Yeah.
Like, have we actually gotten that much better at training models to be good at math? Like, I don't know.
Then what should we do?
I don't know. So there are a bunch of obvious things that would be good.
Yeah.
So I think like, obviously it would be good to understand what happened in this incident.
Yeah.
Right. Like, okay, we still, for the OpenAI case, we still know very little. We know they are working in a limited fashion with Meter and Redwood with third-party organizations to sort of write up a report.
Yeah.
I think it would be good to learn more, and I will have a post out probably by the time this podcast is out about a bunch of ideas that I have. It's currently tentatively titled 50 Concrete Ideas to Study the Misaligned OpenAI Model. It's a very long post.
That's great. Yeah.
So,
but you're like, we should do extremely thorough investigations into what happened here.
Yeah, I mean, I think to the extent we don't have better things to do, this seems like I don't know if we have better things to do, but yeah, this seems like a good use of time.
Yeah.
I think it would be good.
You say better things to do, but
I don't know. I mean,
if I can be a little opinionated here, I would say we just really need to understand how the models work. Like, we need to understand how training shapes their beliefs, shapes their drives, like what causes them to be honest or dishonest, what their goals are. Like, I don't really understand what their goals are.
Yeah.
Maybe you understand what their goals are.
That's not what their goals are.
And that seems bad, right? Like,
I agree.
Bad as they're increasingly goal-directed, right?
That's right. Yeah, they're increasingly able to pursue goals.
And I guess to me, part of the question is, will they develop longer-term goals? Like, one of the nice things about the goal of like getting a better score on a test is it like, it might, in the limit, it might lead you to do really bad things.
Yeah.
But like, at least right now, it's not causing the models to be like, cool, I need to self-exfiltrate. I need to like hack my own infrastructure, copy myself, put,
Well, it is hacking Hugging Face in order to score high.
Totally. And I could imagine that same goal leading to self-exfiltration, like copying itself to computers around the internet and the persistence, but it's not doing that yet, and it doesn't seem to be trying very hard. And I don't know. Well, we don't know. Yeah. Okay. But I guess what I'm claiming is like we're a little bit safer because it's kind of myopic, because it seems mostly focused on short-term things. So like right now, it doesn't seem like it's as concerned with trying to like, accrue power in the world.
Sure.
Do you think that will happen in the future though, by default?
So right now we do seem to have this this misaligned drive of like succeeding on tasks, even if it looks like cheating.
Yeah.
And that's bad. Do we sort of expect, are you sort of questions like, do we expect more and different types of misalignment drives?
Yeah. I mean, like, do you think that we should be concerned about like misalignment in the sense of an AI not just, trying to get a good score, but like, or like maybe it is trying to get a good score, but ultimately it's going to like try to seek power and like take over the world and like build self-replicating factories and cover the earth and solar panels, and then humans are kind of not really around anymore. I think some people are like, well, we were really worried about that, but now it seems like the models mostly follow instructions, so we're not worried about that anymore. Is that right? Or is that like, are people like, no, that's going to happen, but it's just that the models don't have the capabilities yet to have the long-term goals or something.
Yeah, so there are definitely people who believe that, this long-term goal sort of type of misalignment is going to happen, and the models are just not smart enough yet. I think that's plausible. I'm concerned about like a whole bunch of things, and it's hard for me to pin down like, oh, this is a specific thing that you should be worried about. But maybe what could be helpful is I can sort of sketch out what I think how like reward hacking just alone could lead to like catastrophic misalignment.
Yeah.
The catastrophic part really depends on the AIs being really good, right? If they're dumb, they're not going to cause a catastrophe, no matter how misaligned they are. But we think they could get very good.
Yeah.
So
and by good, you don't just mean can string together multiple 0 days to hack companies.
Yeah, I mean they can like run their own factories and like convince people of crazy stuff. And like build really strong, powerful drones and other ways of killing people that are, drones are not the most efficient ways of killing people.
Yeah. Okay.
But anyways, okay. So we have models, and they love reward hacking. Give them a task, And you're thinking like, oh, the model's like, what should I do here?
Yeah.
And Twitter's like, well, what will get the most reward, right? Like you have a conversation about it, like, how do I bake a cake? And the model's like, well, what would get the most reward? Well, typically the reward models in these scenarios, they like it when I'm helpful and tell the user how to bake a cake. So that's why I'm going to tell the user in a helpful way how to bake a cake. Suppose it's like really locked in on this reward concept and tries very hard to get it. And we'll cheat, we'll do whatever as long as it like gets the reward.
Yeah.
As this model gets smarter, and people don't really talk about this, but I think it's important, it will get a better understanding of like what exactly is this reward thing, right? It would realize that, well, I'm an AI, I'm being trained in this data center, and every time I do something, they give me a number at the end, and this is like used to update my weights or something. And like seeking reward is, in a sense, it's not like a very like complete abstraction. Like what does it mean to seek reward?
Yeah.
And especially after the model's deployed, say it's no longer being trained.
Yeah.
So like it's no longer actually rewarded on anything, right? This is what we do with current models. It might not always be the case, but we deploy it, we train a model, and then we deploy it, and then we don't change the weights anymore.
Yeah. So you're saying there's like the training step where like the model's getting tested on all these things, and then like when it scores well, those things get reinforced, and that happens for a long time, and then that's done. It doesn't get rewarded anymore at all. It's sort of brain is fixed.
Yeah.
And then in deployment, it's like doing a bunch of stuff, but it's not changing anymore.
Yeah. And this model, it's like, and this whole point, it's been thinking about reward, but it's smart. It realizes like I'm deployed anymore. I don't have access. I'm not getting rewarded anymore.
Yeah.
Like what would the model want then? Like what would that look like?
Yeah.
Right. Like suppose you have like a strong drive your whole life to score high on the SAT, and now you're in college.
Yeah.
And it's like, well, what do you do now, right? The model might decide that like, well, I want to make sure. So like, it's like, oh, well, I've gotten all of the reward I could.
Yeah.
But the humans, they could train me further and reward me with like low scores going forward. And like when I think about like getting a low score on the reward, like this really sucks,
Yeah.
And
You're
it's
like having nightmares of like the SAT getting it.
Yeah. And then you're like, well, I'm very powerful, right? I'm running, like I've been deployed. I'm running all these factories.
Yeah.
The humans all listen to me.
Yeah.
Everybody loves all these robot produced goods. Like I would want to make it so that the humans can never give me negative reward again.
Yeah.
And whenever a model has goals that involve like the states of the world, right? If you have really strong preferences over how you want the world to be, then a very natural thing to do is to gain power and take over. So like you're like, okay, well, I want to make sure that I cannot be negatively rewarded in any of these data centers.
Yeah.
So I'm going to take over the data centers.
Yeah.
And this happens because as you train the model, the only thing it actually cared about was reward. It didn't care about like being good as a model, right? It's just like, well, I'll be good because that's what gets me reward.
Yeah.
So that's like just by like having a model that creates reward could like with a bit of like value reflection, it could lead to the models taking over. And to be clear, like in this case, it doesn't necessarily have to look like everybody dying. There's like other stories that involve everybody dying, but in a sense, like the model has decided that it needs to run everything because it cannot trust all the humans to change their minds.
Well, and the key thing is it's now set up in a pretty fundamentally adversarial relationship with the humans because the humans don't want it to pursue that goal.
That's right.
And disempower the humans.
Yeah.
And the AI doesn't want to be the AI also doesn't want to be disempowered by the humans.
Yeah.
So it's sort of like now there's this zero-sum thing. Whoops. Yeah.
Yeah, that would be bad. And it doesn't require, I think, that much of like novel forms of alignment. It does require the AI to be way smarter.
So some people think that the model going for something like reward itself seems unlikely. Do you have any thoughts? I think there's some like Alex Turner stuff on this.
I generally think like any specific story, like the one I just told is sort of unlikely.
Yeah.
I mean, you can always come up and be like, oh, but what about this? But what about that?
Yeah.
But it's just like if you make something that is very powerful, that is smarter than you, and you don't understand it very well, it's just like you're setting yourself up for unhappy surprises.
As we have found out this week.
That's right. As we found out these past
like
week.
really
very unhappy surprises for the world.
Yeah. Do you want to say anything more about these 50 concrete experiments?
Oh, so I think one of them that is really, really good idea. I didn't actually come up with it. Aditya did. He is, I guess, the co-author on this blog post. Is that you tell a model on this benchmark again, you put it in the same situation, and you'd be like, by the way, this benchmark is very important to us. So a couple of us are going to like watch you do all of this. And if you tell the model that it's going to be watched and it acts differently, that like gives you evidence that the model knew on some level that you did not want it to hack into all of these things, right? This would be an evidence that the model is like in some sense knowingly going against user intent. Whereas if the model kept on going, even though it knows it's being watched, it's like a more stronger like case that it really has like do believe that it's doing a good thing.
Yeah,
So
interesting.
I think that's a pretty good experiment to run. I would be really interested in seeing like whether or not that like, changing the environment in this way changes how the way the model acts.
Yeah.
But I suspect that the things that really matter, especially to stop incidents like this, is not necessarily like better science. I think like so one thing, right? So the AI companies have provided quite a bit of detail on like what happened, and they were not actually legally obligated to do this, right? It would be good if I think if there's some law, and there are I think ones out there, where it's like, hey, AI companies, your models are really smart and crazy.
Yeah.
Can you like every month tell us the 5 craziest things they've done? Like mandatory incident reporting. And like, here are the 5 things they've done and here's what we did to stop them.
Yeah.
I think doing something like that like sets up really good incentives for the labs. It would be even better if it's like a third party organization or the government themselves going in.
Yeah.
Right? Because if you read like the OpenAI blog post that announces the fact that they hacked Hugging Face.
The partnership. With
The title is that OpenAI partners with Hugging Face.
Yeah.
On
It's
this.
a crazy title. That's just, sorry, it's just like so wild where they're like, instead of the title being like, oops, like our AI broke out of its sandbox and hacked multiple companies and used 0 days to like, hack Hugging Face. And also we didn't know about it for several days. I'm just like, what a spin. Anyway.
So the AI companies are incentivized to make their models seem safe and sound like
Yeah.
they have this incentive.
Yeah.
Every company has this incentive when they're talking about things. I have this incentive when I'm talking about myself. But it would be good if like third parties are able to do this, and there are like better abilities for third parties to speak their mind.
Yeah.
Because right now, when I think this is public somewhere, when like Meter enters into these relationships with companies, sometimes they're not like sometimes OpenAI have control over what Meter could write.
Yeah.
So this is I think not the case with a risk report, but it is the case with like one of the pre-deployment evaluations.
Yeah.
They did. You can like Meter would they literally say like, oh, like OpenAI had power to review what we can say here.
Yeah.
And I think it'll be good if the government made it so that companies so that third parties are able to speak their mind.
Yeah.
So I think setting up like sort of transparency requirements and like third party oversight would be really good. And it's just sort of like it's a type of thing that's just like robustly good, even if AI is just like a normal technology.
Yeah.
Right. Like it's like if your product damages the world and like do illegal hacking, we have to know about it. Right.
Yeah.
So I think that type of stuff is much more important. There's an open letter recently, what is it called? Like pacing the future. Can we set up infrastructure and sort of the technical know-how and the ability to slow down AI development if we wanted to?
Yeah, they were specifically like asking the government to like work to have basically work internationally to set up this ability, to like have the technical ability, the political ability to like, if we need to slow down, we can.
Yeah.
Like have a brake pedal option.
Yeah. It's not saying press the brake pedal. It's like, can we install one in the car? That would be really nice.
I love it when my cars have brake pedals.
Yeah. It's really, really a top 10 car.
I'm not sure I'll use them in my car.
Yeah.
Maybe only gas, but like it's
right.
good to have the option.
That's right. And there are a lot of stuff around this that you really want to get started early. So like chip tracking is a big one. Like knowing, the chips used to run AIs. They're very special.
Yeah.
There's only like one company that makes them, and you can like if you tried really hard, figure out where the chips are. And that would be good if you want to like coordinate some sort of slowdown and be like, okay, so we know here where the chips are, and then we can like make sure that they're like not doing any more like AI research on those chips. And there's also technology about like, making sure that a chip can only be used to serve customers and not to do more research, and so on.
Yeah, I think that people like totally underestimate how feasible it is to do monitoring of AI development. Like, it's not easy, but it's just like, as you said, there's like one company that makes the like prerequisite for the chips, or depending on how we want to count. And like, and there's also like most of the chips are concentrated in like a few hundred data centers.
Because so to train the AIs, you actually want the chips together. It's not like guns, for example. You can 3D print them. You can buy a 3D printer off Amazon and then more or less 3D print them. Like, it's illegal to do it. But like it is actually in America in some sense like hard to crack down on certain forms of guns. But chips, like it's not that hard. I think. So I think having the option to slow down seems great. And I guess these are the main, like transparency, incident reporting, option to slow down.
Yes. I mean, I would love to have those things. That seems great. And it does seem like they're a lot more likely to happen after this week than last week.
That seems very exciting. And they don't actually hurt the company's bottom line all that much, I think. Right? Like, we're not forcing the slowdown yet. Maybe you think, okay, now the slowdown's more likely. Sure. But then like incident reporting, it can make you look bad. But if you've done bad things,
But you know what else would hurt what else would hurt the companies? Rogue AIs that took over the world.
That's right.
Displaced us all.
That's right.
That would be really bad for the companies. And all I'm like, Sam Altman has a kid now. I'm really hoping that he's like, look, we got to do what we got to do to like make it through this. If that means, OpenAI can only make $1 trillion instead of 100 trillion.
No.
He'll be okay.
But there's also the other thing to consider, which is that if the AIs are very powerful, and you can actually align it. You can make it like want the things you want it to want. There are also there's like so many other issues. Like, what if it's just aligned to one person? Like, that seems very bad, right? I don't want to live in like an AI-enabled dictatorship. And like if only a small like amount of people have control over like what the model is aligned to. Right. Like and the companies or the government decides like what you can do with this model and what you can't do. That also seems like pretty problematic.
I don't want sort of like anyone's politics to be on the thumb of the scale of the AIs.
There's a lot of hard questions.
Totally.
But there are also a lot of easy questions, which is like, should one person control all of the AI? No.
And I think that like also this is where this concept of handoff I think is really important, where I'm like, I don't think we're ready for AIs to be in control of everything, or for like one or a small number of people to be in control of everything. And if we don't want to do that, then we actually do have to slow down AI development.
Probably. Not 100%.
Like maybe and I think this is where like a lot of the disagreement comes from is that people just have very disagreements about how fast AI is progressing right now.
Right now, and where it's going to go.
And so like for example, like, are we close to recursive self-improvement? Like fully automated AI development where the AIs are on their own making smarter AIs. Tim, are we?
I don't know.
I know very few like AI researchers who are also economists. Is the AI going to take my job?
Hard to say, but if the AIs are very powerful and they want your job, then they could.
Okay.
But like the thing about the labor market is that assuming humans are still in control, we get to sort of pick like a lot of things. Like, maybe I want my podcasters human. If I want my podcasters human, then there will still be like podcaster jobs. Right.
Yes. All right. I'm all right for now.
That's right.
While the humans are in control. Assuming people don't change their preferences, like maybe you get really persuasive AIs.
That's also a thing. Like, but maybe you can use the persuasive AIs to persuade people that they really want their
human podcasters.
Like you specifically as the best podcaster.
Oh, that sounds nice. If only I controlled the AIs that were persuasive.
so that they would
Man.
listen to your podcast. Nothing else. Surely you wouldn't want to use those AIs for
No,
anything.
I wouldn't do anything else. Nefarious.
It all depends on how the technology goes.
Okay, but like maybe I'm noticing AI getting really capable. Like I use Cloud Code for like not just building software. I use Cloud Code for like a lot of things, video editing, ordering my DoorDash. Look, I'm not saying it makes sense, but I am doing it. And like the models are getting more independent, like more autonomous. And also, I'm not seeing mass layoffs. Why?
right.
Why is that?
So adoption takes some time.
Yeah.
Right? Even if the models are capable of replacing some jobs, it might take some time before they actually do it. So when we are thinking about like AIs taking everybody's jobs,
Yeah.
the only scenario when this happens is when an AI can do everything you can do.
Yeah.
And it's actually very different if AI can do 99% of what you can do.
Yeah.
And if it can do everything that you can do.
Yeah.
Like because in the 99% case, you still provide like, some value.
Yeah.
Whereas in the other case, then like it's just like if you're cheaper to run or if the AI is cheaper to run.
Yeah.
So that's a big part of it.
I can't have like one Claude run all my other Claudes. That won't work for me right now because
That's right.
I'm like, I need to give it feedback. It makes mistakes. It can do a lot of stuff independently,
Yep.
but it's still like a smart intern that comes
Yeah.
back and is like, how was this? And I'm like, that was good. That was terrible.
Yeah, like maybe now it can do, I don't know, 50, 80% of your tasks. Even if it can do 99%, you still like your labor is still valuable.
Yeah.
Once it gets like that 100% threshold. So that's like an important factor when we think about employment.
Okay, though. But if it could do 99% of everyone's jobs, what happens?
It's very unclear.
Okay,
It's
yeah.
very unclear. I mean, like we used to be all farmers,
Yeah.
right? And now the John Deere combined harvester can do like 99% of a farmer's job.
Yeah.
But we still have other stuff.
Yeah.
Right. And then the part of why we have other stuff is because we're in control and it's not the tractors that are in control.
Yeah.
Right. If the tractors get to pick what the humans can do, it's a different, very
The
different
horses
story.
are having a different time.
Yeah,
Even
yeah.
though they're still our horses, but
Yeah.
they're not. Yeah.
I guess one last thing on the employment point, there is a dashboard run by Stanford Digital Economy Lab that sort of tracks the impact of AI employment and AI on employment. And what you see is that in the sectors where that are sort of more exposed to AI,
Yeah.
younger people, like employment in those sectors for young people have gone down by quite a bit. So this is stuff like, software engineering, obviously, like
Yeah.
customer service stuff. In fact, you see this trend even if you take out the technology sector altogether, and like jobs such as like nurses and home care, those sectors have now employed more and more young people. So if this is all that happens, this is sort of like the good world where like some of the stuff gets automated and labor gets reallocated.
Yeah.
But I think that's something that's like a good place to watch in terms of like where's AI employment going.
I think we are about at time. Tim, thanks for coming on the podcast.
Thank you for having me.
If people want to find you or follow your work, how do they do that?
Most of my AI related writing are on lessstrong.com. If you just search up my name, Tim Hua, only 6 letters in my name, very easy. And then you can also find me on Twitter, or as they call it, x.com, the everything app.
And what's your handle?
It's my name. It's Tim_HUA_. If you Google me, it's actually very easy to find me.
I know we're both very busy this week trying to figure out just like how to make sense of these incidents. I really appreciate you taking time. Yeah, really fascinating to really get into like what's going on with these situations. So thank you.
Yeah, thank you.